Hi everyone, welcome to part 2 of the lecture video series for Chapter 1, Introduction to Statistics. Dr. Bianchi here, and if you haven't already, you should have watched part 1 lecture video covering the first half of the chapter. This is now part 2, where we're going to go a little bit more in depth into different kinds of data structures, ways of setting up data, different kinds of research methods and ways of designing studies, and tying all of that into statistics. Okay, so in this section, we're going to be looking a little bit more at how we can conduct research in the social and behavioral sciences and what kinds of ways we have for setting that up, and how statistical analysis is intricately linked to the kinds of study designs that you choose to employ when you do your research. So we are already familiar with the term variable. Okay, again, a variable is anything we can measure that is different between people or changes over time. And we go out when we do research because we're interested in measuring variables. Okay, I might be interested in the amount of coffee that students consume. I might be interested in height or weight. I might be interested in symptoms of clinical depression. All of these things can be measured, and we use statistics to describe the observed variable. Okay, another example of a variable is performance on exam 1. Well, the average score, the average grade in the course is an example of using statistics to give a big picture perspective into how the class performed. Okay, we also have variables that are non-numerical. I can ask, what color pen are you writing with? Or what is the most popular color pen ink in the course? Maybe it's black, maybe it's blue, maybe it's some other color. Okay, but variables are things we can measure that we're interested in. Now, often we're not just interested in individual variables, but we have an idea that there might be a connection between two variables. Many research studies want to examine relationships between two or more variables. For instance, is there a relationship between the amount of violence that children watch on TV and on the media and the amount of aggressive behavior that they display? Is there some connection there? Is there a relationship between what kinds of nutrients you consume at breakfast and your academic performance? Okay, is protein consumption or carb consumption linked with academic performance? Something like GPA. So typically we want to look at multiple variables and see if there's some kind of connection. When we are looking at relationships between two variables, there's two different data structures or setups that we can use. The first is the correlational method. You've all heard before that correlations do not equal causation. Okay, correlations allow us to say, hey, these two variables seem to be connected, but they don't tell us why. If we're conducting a correlational study, we're going to have one group of participants. Let's imagine everybody enrolled in the course right now. And we're going to measure two variables for each participant. So I'm going to measure how much protein in grams you consume for breakfast and your GPA. Okay, I have two different variables there. Everybody in the class has two data points. And the goal of this research design is to describe whether or not there's a relationship. If so, in what direction is it going and how strong is it? What's the magnitude of that relationship? Patterns in the data are going to reveal relationships. Okay, so this allows us to determine whether or not there's a connection between two variables of interest. It's important to remember that this is a non-experimental method of study. That means that the conclusions that we can determine from this kind of research are limited. Just because two variables are connected in some way does not mean that they cause one another. There may be a relationship between protein consumption and grades. It doesn't mean that if you eat a bunch of protein tomorrow, you're going to be a straight A student. Okay, just because we can demonstrate a connection does not mean that we have demonstrated causal proof. Okay, in order to talk about cause, every time A happens, B happens, we need to run an experiment, which is a specific and sophisticated type of research study. We'll be talking about that in a few moments. So here's an example of some data for a correlational study. Over here, we have a bunch of different students that have been measured in terms of their wake-up time each morning and their GPA. Okay, and here the researchers are wondering, is there a correlation between the time that you wake up in the morning and your academic performance? Okay, perhaps the prediction is that early risers are going to have better academic performance than people that sleep in. Now, that is falsifiable. The data may or may not support that, but we can look at that through a correlation study. Over here, you can see the different wake-up times and the different academic performances associated with each person. Each student has 2 data points, the time they wake up and their GPA. Over here on the right side of the screen, we have simply graphed these results in what's called a scatter plot. Okay, so somebody wakes up at 8, their GPA is a 3.0. Oops. Somebody at 9 wakes up. We have 2 people who report waking up at 9. One has a 3.2 and one has a 3.6. Overall, this scatter plot gives us sort of a trend, right? This looks like a negative relationship. As people wake up later, GPA looks like it goes down. Okay, but keep in mind, this is a really small study. There's only 10 people in the study. What would happen if we studied 50, 100, or 1,000 students? Okay, the data may fill in and look quite different. I just want to give you this example of a correlational study looking to see whether there's a relationship between academic performance and wake-up time. Correlational methods can demonstrate the existence of a relationship, but they do not provide an explanation for the relationship, and most importantly, they don't demonstrate cause and effect. I'm going to give you sort of a funny example here. It's well known that there's a very strong positive correlation between eating ice cream cones and drowning in the ocean. Those things are correlated in a positive and consistent way. Now, most of us would not feel comfortable saying that eating ice cream cones causes drowning. Okay, there is a third variable that explains why that connection exists, and that third variable, you may have guessed it, is warm weather. Okay, when it's warmer and hotter out temperature-wise, people are eating more ice cream and they're also swimming more and more people drown. Okay, so just because we can show that 2 things are connected does not imply that they cause each other. Cause is a technical term. It means that every time the first event happens, the second event follows. Correlations are unable to display that. We must run a formal experiment in order to talk about cause and effect. So what I want you to do right now, similar to the first video, is I want you to pause this video right here, and directly underneath this video in D2L, you're going to see a short TED Talk that I've linked to, and it's called The Danger of Mixing Up Correlation and Causation. I want you to stop here and attune to that video. It's about 7 minutes, and the speaker does an excellent job of giving us some different examples from the sciences, from all sorts of research, where people have confused correlation with causation, and some of them have led to very serious mistakes. It's thought that confusing correlation and causation is one of the most common logical errors that the human mind makes. Okay, so go ahead, pause here, check out that TED Talk. There will be questions on the exam about it. It really provides a good overview of some more realistic examples of this problem, and then you can go ahead and return to this lecture video. For your own interest, I've also provided a link to a really funny and interesting blog. It's called the Blog of Spurious Correlations. And the blogger basically goes around and finds all of these really strange correlations that kind of make no sense. Okay, they're just random things that are related, like the number of films that Nicolas Cage has appeared in, and amount of people that have died from eating butter. Okay, all sorts of weird connections and correlations. It really does a good job of reminding us that just because 2 things in the world are connected doesn't mean that they cause each other. Okay, we can find all sorts of strange connections. It doesn't imply cause and effect. Okay, so check out that blog if you're interested. Students usually find it really funny and fascinating, and I've posted it for your own viewing. If we want to look at the relationship between 2 variables, we can do a correlation study, which we've just covered, where we have 1 sample of participants and we measure 2 variables from each person. We have 2 data points on each individual. An alternative way of looking at relationships is to compare 2 or more groups. Okay, we can group people up and see if there's a difference in their scores. So for instance, let's just imagine that, right, I teach the hybrid statistics course, okay, and I also teach a traditional lecture statistics course that meets on campus regularly and is always getting the material in person. Maybe I have some prediction, right, that students who learn online in more of a hybrid way, they might be more independent, something like that. I expect them to do better in the class on average than students in the in-person lecture. What I can do is say, okay, one variable is the format of the class, hybrid versus in-person. And the outcome measure is grade at the end of the course or average exam grades. Okay, and I can see, is there a difference between hybrid students and in-person lecture students in their academic performance in the course? Now, this can be non-experimental, the way I just described it, right? You've both selected what format of the class you want to be in. You've chosen the hybrid format, or perhaps you chose the lecture format. And I'm just seeing if there's average differences across those two groups. Or maybe 50 students at the beginning of the semester want to take statistics, and I randomly assign you to one of the class formats. Okay, you're going hybrid, you're going in person. You're going hybrid, you're going in person. Now, this would never really happen, obviously, due to logistics and the fact that you're in charge of picking your own schedule. But if we were thinking about it sort of abstractly, I could randomly assign students to one or another condition of taking the course and see if there is a difference in their exam scores. That would be experimental because I am manipulating what version of the class they attend. I am in charge of dictating that. Okay, non-experimental is, okay, here's 30 people who signed up for the hybrid, here's 30 people who signed up for the in-person. Let's just see if any differences exist. Okay, but the key idea here is that we can also look at relationships between variables by grouping people up. Okay, does your group status relate to your results? Here's an example of that. Another example here, in one group we have children who have been exposed to a lot of violent TV, and in another group they have no exposure to violence on TV. And then we can measure aggressive behavior in the playground. Okay, and compare the groups of scores. Is there a difference in playground aggression between the violence and no violence groups? Okay, this is a correlational study. It allows us to see whether or not there's a connection between media and TV exposure to violence and actual aggression. Now, it would be non-experimental if I simply said, hey, people who have watched a lot of violence, you're in this group. People who haven't watched a lot of violence, you're in this group. It would be more experimental if I said, okay, 20 students are going to watch violent TV for 2 weeks for 3 hours a day. 20 other students are going to watch nonviolent TV for 2 weeks for 3 hours a day. And let's see if it impacts their aggressive scores. Okay, in that case, I would be manipulating violent exposure, or I can simply observe things as they exist. Okay, so there is our first kind of key research design, right? We want to see if there's a relationship between two variables. We can do it through a correlational study where we take one sample and we measure 2 data points on each person, or we can do it in a group type of a study where one variable defines the groups and we want to see if group status has an outcome on the outcome variable. Okay, let's go ahead now and move into the experimental method. The experimental method is the most sophisticated research design that we have available to us. Okay, the goal of an experiment is to demonstrate a cause and effect relationship between two variables. Okay, more precisely, an experiment attempts to show that a change in one value of a variable is directly linked to a change in another value of a variable. Okay, to accomplish this, experimental methods have a couple of unique components, okay, or characteristics that differentiate them from other research studies. One is manipulation. The researcher actively manipulates one variable by assigning or changing its value from one level to another, and then measures a second variable to see whether or not the manipulation impacts the outcome. Experiments are also marked by what's called control. The researcher or the research team has to exercise control over the entire research situation to ensure that other outside variables don't contaminate or influence the results. Okay, so when we look at an experiment, we have the active manipulation of one variable, okay, to see if there's an outcome that's different for those conditions. A great example is a clinical drug trial, okay? Half of the sample gets a sugar pill, the other half gets the active ingredient. Do symptoms or diagnoses go down? Okay, we rule out the influence of other variables. People take the medicine at the same time. We make sure there's an equal amount of men and women. The participants are of similar age. We make sure that they're all of a similar level of being sick, okay, in terms of their status of where they are with the disease, that sort of thing. Okay, so things like age, gender, intelligence, these kinds of things that vary from participants have to be controlled, as well as environmental variables, okay, characteristics of the environment, the lighting in the room, the time of day, all of these kinds of things can impact results. Researchers want to try to control these variables as much as possible. One of the best ways they do this is by using random assignment. That means that each participant in the study has an equal chance of being assigned to each of the treatment conditions. Okay, participants don't pick what group they're in, they're randomly assigned. So to summarize, in the experimental method, one variable of interest is actively manipulated by the researcher, while an outcome variable is measured and observed. In order to show cause and effect relationships, an experiment attempts to control as much as possible all of the other variables that could contaminate and influence the results, thus making the experimental method one of our most sophisticated study designs in the sciences. Here's an example of an experimental study. Okay, here participants are randomly assigned to one of two conditions, either counting money, okay, actual dollar bills, or counting blank pieces of paper. Later, each participant was tested to see if they would have higher or lower pain ratings when they placed their hand in a bowl of hot water. Okay, there was some idea that if you were counting actual money, dollar bills, you would be distracted, you would feel pretty good, and you might rate the water as less painful than if you were just counting blank pieces of paper. Okay, we have to be open to the results to come up either way, but here we have randomly assigned people to either count money or count paper, and we can compare the groups in terms of the average pain score that they provide. Okay. The condition of counting money versus counting paper, that's referred to as the independent variable, okay? The independent variable is the variable manipulated by the researcher. Put differently, the independent variable is what we think causes the outcome, okay? We think it causes the dependent variable. The dependent variable is the outcome measure. It's dependent because its result is thought to depend on the value of the independent variable. So if you look at this study here, the independent variable is whether you're counting money or paper, okay, counting condition, and the dependent variable is the pain rating. Okay, very important terms. Sometimes the independent variable is simply called the IV, and the outcome dependent variable is called the DV. Okay, if you're going into research methods, any kind of science, these terms are going to never go away. So you really want to get them down right now. They are fundamental to doing any kind of research or study in the social and behavioral sciences or in any STEM field. Okay, just again, I've already talked about this, but experimental methods are marked by control. Okay, there's a lot of attempt to control outside variables, noise, things that could influence your study. Okay, randomly assigning individuals to conditions, making sure there's a match of subjects. We have an equal number of men and women in this group, or an equal number of third graders and fourth graders in this group. Okay, we want to hold all outside conditions constant as much as humanly possible. Okay, we can't control everything, but we can control the things that we think could influence our study. The control condition in a study is usually the control group. They don't get the active treatment, they get the sugar pill, they get the placebo. Okay, they provide a baseline comparison. The experimental group or the experimental condition of the study actually receives the active experimental treatment, the real drug, the actual therapy. We're typically comparing the experimental group to the control group, usually hoping that the experimental group who's received the actual treatment is going to perform better, show less symptoms, etc., etc. Okay, let's go ahead and do a couple of practice questions because we've been covering a lot here. Researchers observed that student exam scores were higher the more sleep they had the night before. This study is A, descriptive, B, an experimental comparison of groups, C, a non-experimental group comparison, or D, correlational. Okay. More sleep, better exams. Okay, correlational study. We have 2 values measured for each person. Okay, there seems to be some kind of connection here. Let's go ahead and do a couple of true-false. True or false, all research methods have an independent variable. All research methods have an independent variable. Okay, go ahead and jot down your answer. And then let's go to the second one. All research methods can show cause and effect relationships. True or false? Okay, these are both false. The only kind of research study with an independent variable, a variable that's manipulated, is an experiment. Okay, most of our research designs do not contain an independent variable. And only experiments control the influence of participant and environmental variables and thus can have something to say about cause and effect. Okay, really important points. So if you're doing research in an area, correlation studies are great. Okay, they're a great place to start. They give you a really good idea of what's going on. If 2 variables aren't connected in any way, you have no business doing an experiment. There isn't even a basic connection there to be studying. So you always want to start with correlations, but once you've established that there's a connection between 2 variables, now let's go ahead and manipulate one of those variables and see if it influences the outcome. Let's go ahead and do a more formal experiment that's going to allow us to be more confident in cause and effect conclusions. Okay, so now what we're going to do is we're going to move into another major segment of this foundational chapter, looking at how we can actually measure variables. And as you'll see in psychology, in the behavioral sciences, measurement is quite complex. Okay, it's not as easy as measuring how many ounces are in a cup of water. We want to measure things like stress, anxiety, how intelligent somebody is, what's their current mood, how angry are they, what's their personality. All of these things are abstract concepts that are difficult to clearly and neatly measure. So when we engage in measuring variables in the social and behavioral sciences, we're going to have to go through a process. Okay, a series of procedures that's very carefully laid out. Very, very key distinction here in this course is one between constructs and operational definitions. Constructs are internal attributes or characteristics of an organism that cannot be directly observed. Okay, things like mood, stress, personality, intelligence. Okay. In order to measure those kinds of constructs, those abstract concepts, we need to form what's called an operational definition. An operational definition is how we're going to brass tacks measure this variable. How am I going to quantify or measure your mood? How am I going to measure your stress? Okay, what am I going to do to measure an external observable behavior? Okay, so I might be interested in aggression as a construct. Now, there's all different kinds of aggression. There's verbal aggression, there's physical aggression, there's passive aggressive behavior. It can get very complicated. But perhaps in my study on 3rd graders, I'm going to measure aggression by the number of physical kicks, punches, and hits that we see on a playground over a 30-minute period. Perhaps in another study, aggression is going to be measured through a survey, asking individuals how often or how frequently they have engaged in different kinds of aggressive acts over the past 3 months. Okay, so constructs are the variables we want to study. The operational definition is, all right, let's get down to practicalities and logistics. How are we going to actually measure this stuff? Okay, a construct could be intelligence, IQ. The operational definition is the specific intelligence test that's administered to the person, and it's going to have its strengths and its limitations. So what I want you to do right now is pause the video, and I want you to think of a construct that you're interested in, okay, in psychology, in any field that you're in, and then go ahead and operationally define it. How would you measure that if you were studying students at the college or university level, or people out in the community? How could you actually measure that variable you're interested in? Okay, it's a useful exercise. Go ahead, pause here, and see if you can come up with an example or two. Okay, so hopefully you paused and were able to put together an example or two. Here's one that I came up with. I am really interested in measuring student stress levels. How am I going to operationally define it? Well, right before midterms and finals, I am going to get a saliva sample from students and measure circulating stress hormones in the body. Kind of fancy. What about another one? I'm interested in clinical depression and symptoms of depression. How am I going to measure it? I'm going to administer a well-established survey questionnaire that measures symptoms of depression and see the variation in scores across individuals. Here's another key distinction. Some variables are discrete. They're black and white. There are separate categories. There are differences in kind. If I asked how many kids are in your family, right, it's 1, 2, 3. You can't have 2.5 kids. You can't have decimal points on that. If I ask you how many chairs are in a classroom, it's going to be a separate indivisible number. Okay, a continuous variable, in contrast, has an infinite number of possible values. Okay, we basically see decimals and fractional parts. I might weigh 130 pounds. You might weigh 130.7 pounds. Okay, when we talk about continuous variables, we're talking about variables that are not black and white categories. Okay, continuous variables have real limits. So if somebody scores 150 on a test, we have to remember that that also encompasses anybody above 149.5 because they're rounded up, and anybody scoring 150.5 and below, they're rounded down. 150 encompasses individuals who fell between these limits. These are known as the real limits of an interval when we're talking about continuous measurement. Okay, here's another example. If you end the course this semester with an 89.8, I know you would probably be emailing me asking me if you're getting an A, and you would get an A. I round up at the 0.5 level. I think it's kind of cruel not to. And your 89.8 would be a 90. Okay, same thing if you had a 90.4, you would still be considered a 90. Okay, still an A, but you would be a 90. So real limits are important, okay? The upper and lower boundary of each interval. It's going to come more into play next week when we look at graphing data. So I'm not going to go crazy on this. I think the book goes a little too much in depth into real limits. Okay, just remember how rounding works and you've got it. Okay, going to come into play when we start graphing results on charts and graphs and that sort of thing. What I want to move to now are the different scales of measurement that exist when we are measuring variables. The process of measurement assigns individuals or events to categories. These categories can be name-like, things like male, female, employed, unemployed, married, single, divorced, or they can be numbers. Okay, 68 inches, 175 pounds. Okay, measurement is all about assigning individuals to values, to categories. They may be numerical or they may be purely categorical. The complete set of categories is what we call a scale of measurement. This is a table that is a great study guide. There are various scales of measurement that we can use. Okay, and what I've done here is I've summarized the characteristics of the scale of measurement, and I've given you some examples. When we talk about a nominal scale, we're talking about categories that have names, okay? There's no numbers here. Okay, measurements on a nominal scale label and categorize observations, but there's no numerical distinction between them. Okay, gender, diagnosis, positive or negative, what group are you in, the experimental or control, these are all examples of nominal variables. An ordinal scale consists of a set of categories that are organized in sequence, okay, that are put in an order. Okay, measurements on an ordinal scale are going to rank observations in terms of size or magnitude. Okay, what rank are you in the class? What size clothing do you wear? Olympic medals, gold, silver, bronze. These are ordinal types of variables. Interval data is by far the most common in the social and behavioral sciences. An interval scale consists of ordered categories, and all of the intervals are exactly the same size. Okay, equal differences between the numbers on the scale reflect equal differences in magnitude. Okay, 10-point difference is the same high up as a 10-point difference down low. However, the 0 point is arbitrary. Okay, think about temperature. A 0-degree temperature doesn't mean the absence of temperature, it just means it's really cold outside. Okay, a 0 IQ score, it doesn't mean that you know nothing, it just means that you didn't do well on the test. Okay, in an interval scale, we're dealing with numbers, but the 0 point is arbitrary. The 0 or a score of 0 on that variable does not reflect the absolute absence of that variable. Okay, just think of 0 degrees. Okay, it's still cold outside, that's still a valid temperature. Ratio scales are numerical. The only difference is that there's an absolute 0 point. Okay, so when we see 0 on a ratio scale, it means there truly is the absence of that variable. Okay, so if I asked how many questions did you get correct on the first exam, it is possible that you got no questions correct and the answer is 0. Okay, it's possible that you haven't gained any weight in the past year or that your height hasn't gone up. Okay, ratio is still numerical data, but it has an absolute 0 point. Now, I know this is a lot of terminology and very technical, but one thing I really want to emphasize is that when you conduct research, the ways in which you measure your variables have drastic consequences for what kinds of statistical tests are available to you. Okay, when possible, you want to measure your variables using numbers, using intervals. Okay, you only want to use categories if you really have to. Okay, you always want to work with numbers if you can, just a takeaway point. Okay, we have different statistical tests available for interval data than we do for nominal data or ordinal data. Okay, I'm going to skip this one actually, and let's just go to these true-falses. True or false, variables that cannot be measured directly cannot be studied scientifically. True or false? Hopefully everyone is saying false because this course wouldn't even exist. Absolutely, in psychology, the variables we're interested in are more abstract. It's more complicated and we have to be more creative with how we study things like mood, aggression, personality, intelligence, but we can measure them and we do so through using operational definitions, following a set of procedures that allow us to measure and quantify that variable. Let's go to the second one. Research measurements are made using specific procedures that define constructs. Okay, absolutely. That's exactly what an operational definition is. I know it's a big mouthful. I still trip over it even teaching the course for several years. Okay, operational definition, they assure consistent measurement and tell us, hey, in this study, how was stress measured? In that study, how was student satisfaction measured? Okay, on the surveys you take when you complete a class, did you learn a lot? Did you find the course valuable? Did you think the instructor did a good job, right? The college or the university is defining, student, the student liking the course based on how you respond on those survey questions, okay? The class performance or the class, what's the right word? I'm like missing it right now. The class review of how the course went is operationally defined by end of semester surveys where they ask for your input about how the course went. Okay, so we have introduced a ton of concepts in this chapter, very, very important concepts. They're going to play out all semester. Okay, you really want to get all of these key ideas down in this chapter. Statistical notation is also something that will be coming up constantly. Okay, if you can add, subtract, multiply, divide, and follow the order of operations, okay, please excuse my dear Aunt Sally. I don't know if they're still using that in schools, but that's what I grew up learning. That you're going to be good, okay? But if you don't know how to kind of read a formula and follow the correct sequence of steps, you need to go look at the mathematical review in the textbook. Appendix A has a quick math review. Could be really useful for you to brush up your skills. There's a lot of notation that comes up in statistics. Scores are typically referred to as X and Y. X and Y are stand-ins for variables. X could be the amount of coffee you drink in ounces, and Y could be your stress levels, okay, as measured by a survey. When you see the capital letter N, that's the number of scores in a population. Small n is the number of scores in a sample. The summation sign is huge in statistics. Many of our procedures are going to require us to add up a set of scores. Whenever you see this weird looking symbol, okay, the summation sign, it means that you need to add up everything that comes after it, okay? So just keep in mind that here we have the symbol, okay, and then followed by an equation of what's to be added up. Okay, this is the order of operations stuff I'm talking about. Summation is done after operations in parentheses, squaring, multiplication, and division. Okay, but the summation is done before you add or subtract. Okay, so addition and subtraction are the absolute last things you do. Okay, so if I had a formula, the first thing I do is everything in parentheses, then I square the exponents, I do my multiplication, my division, then I do summation. And then after summation, I do addition and subtraction. A little nuance there that's important to note. So let's see if we can get this one. Okay, look at that formula. What is it telling you to do? Okay, take a minute to look at that formula and the different options and see if you can figure out the correct sequence of steps. Okay, so here we are, we're looking at this formula, right? The first thing here to do, we don't have any parentheses, so let's go with the exponent. We need to square each x score. Okay, now remember, summation comes before addition, so the next thing would be to sum it all up. And then at the end, we would add 47. Okay, square each score, add up the squared scores, and then add 47 to that total. If that is confusing to you, you must check out the mathematical review. Okay, Appendix A, there just simply isn't time in the course to review the prerequisite math. That kind of mathematical knowledge is assumed. Okay, if you're struggling with that, get into that review ASAP. Okay, brush up on some of this stuff. Okay, there's a variety of different assessments, math skills, reviews. All of this stuff is available in your textbook on MindTap. There's different quizzes you can take just to make sure you're totally ready math-wise for the course. Okay, so that's going to wrap up our first major chapter. Okay, equations, concepts, questions. Well, guess what? We meet in person, so I want you to hold off and bring those questions to class. I'm going to be addressing anything that came up, confusion, any questions you might have, write them down, bring them to our meeting. That's the whole point of the format of this course. You're learning independently on the computer, and then you are bringing your questions and anything you might be thinking of that's relevant to class so we can work it out in person as a group. Okay, so that's going to wrap up chapter 1. Feel free to go ahead and take a few shots at those MindTap quizzes. Okay, you get a couple of attempts, and you should go ahead and at least take one attempt before we meet on Monday. Make sure that you, give it a shot before then. That way, if something comes up in the quizzes that you're not sure of, you can also bring that to class. Okay, so I'm going to log off here, and I will be seeing everybody on campus really soon. I'm sorry you're not able to see my face right now. I'm actually having a problem with my webcam on my laptop, so I'm in the process of getting that fixed. But I will be seeing all of you very shortly, and in the meantime, make sure to review the textbook and get going in MindTap. Okay, I hope you have a great rest of the day, and I'll see everybody soon.